Welcome to this MTech 101 online class. In this video, I will show to you the procedure when making the planning stage of a passage plan. Planning stage. In this stage, you will arrange the nautical chart, making sure all the voyage chart and publication are up to date, laying down the routes and track from berth to berth, determining no-go areas, marking margins of safety, inserting waypoints, marking parallel indexing, and more. In planning stage, you have to plan for ocean and open water tracks, coastal and estuarial tracks. You have to determine the buoyage system, the fixing frequency, the reporting points. You have also to consider the track, distance of danger, chart overcrowding, and chart change. You have also to determine the pilot boarding station, abort areas in case of emergency, the contingencies, undercare clearance, course alteration and well over point, landfall, and other things. This stage is the most tedious in all the 4 stages. So, as a student going on board, you should have at least an overview on how to do the planning stage. The planning stage may be considered in hub stages: ocean and open waters, coastal and estuarial waters, though at times these 2 stages will merge and overlap. On the basis of the fullest possible appraisal, a detailed voyage of passage plan should be prepared, which should cover the entire voyage or passage. On this stage, the plotting of the intended route and track of the voyage or passage on appropriate scale of chart. On this stage, the officer will plot the intended route and track of the voyage or passage on the appropriate scale chart. The true direction of the planned route and track should be indicated, as well as all areas of danger, existing ships routing and reporting system, vessel traffic services, and areas where marine environmental protection considerations apply. In this stage, charts will be collected together, all the charts for the intended voyage, putting them into the correct order. Charts not absolutely necessary for the voyage, but which are adjacent to the area to be traversed should be included, as should very large-scale chart or plans on coastal parts of the voyage. The officer will ensure that all charts and publication have been corrected to the latest notice to mariners available, and that any authentic navigational warning received from any source are also included. So, charts will be collected together. Charts that are absolutely necessary for the voyage but which are adjacent to the area to be traversed should be included, and should very large scale chart or plans on coastal part of the voyage. The officer of the watch shall ensure that all the chart and publications have been corrected to the latest notice to mariners available on board, and that any authentic navigational warning received are also included. Marking of no-go areas. Coastal and estuarial chart should be examined, and all areas that the ship cannot go must be carefully shown by highlighting or cross-hatching, like this one. These are no-go areas. In waters where tidal range maybe not be very large, no-go areas will include all charted depth of less than the ship's draft plus the given safety margin. Initially, all areas and danger showing charted depth of less than the draft plus the safety margin should be considered no-go areas and should be marked at cross-hatching. Such areas will need to be carefully marked, showing the times and state of tide at which they are safe. Marking margins of safety. Before the truck are marked on the chart, the clearing distance from the no-go areas needs to be considered. When fixed is plotted on the chart, it invariably represents the position of a certain part of the ship's bridge at the time of the fix. These are margins of safety. As you can see, these are not less than, not more than, meaning if you can see not less than, meaning not less than the charted course, not less than the charted bearing. If you see NM, then not more than, NMT, not more than the bearing or course, bearing or chartered course. A safety margin is required around the no-go areas at a distance that, in worst probable circumstances, the part of the ship being navigated, the bridge for example, will not pass. They can be readily monitored. Margins of safety will show how far the ship deviates from the track, yet still remain in safe water. Ocean and open water tracks should first be drawn on a small-scale charts according to the decision made at the appraisal stage regarding the route to be taken. Grid circle and composite grid circle tracks will have to be calculated or obtained from the GPS or from the grid circle chart. Rhumb lines may be drawn straight onto the Mercator chart, but all tracks will have to conform to the limits at appraisal stage. Coastal and estuarial tracks. Coastal and estuarial tracks will also be constrained by the decision made at the appraisal stage and should be first drawn on a small-scale chart covering large portion of the coastline, preferably from the departure port to the arrival port. Change chart. When changing charts, it should be quite clearly shown on the chart the position where it is required to transfer to the next chart, giving the next chart number. Track consideration. As a general rule, there is nothing to be gained by closely approaching a danger other than to reduce passing distance and consequently stemming time. When it does not become necessary to approach a danger, there are general minimum rules that need to be followed. Distance of danger. It is not possible to lay down hard and fast rules regarding the distance of danger that a ship should maintain. It will depend on the draft relative to the depth of water, the weather conditions prevailing, a strong onshore wind or a likely onset of fog or rain will need an increase in distance of the direction and the rate of the tidal stream or current, the volume of traffic, the age and reliability of the survey from which the information shown on the chart has been derived, and lastly, the availability of safe water. Vessels draft less than 3 meters pass outside 5 meters contour. Vessel draft 3 to 6 meters, pass outside the 10-meter contour. Vessels draft 6 to 10 meters, pass outside 20-meter contour. Vessels with a draft of more than 10 meters must ensure that there is sufficient underkeel clearance, exercising due caution with the 200-meter line. Underkeel clearance. In certain circumstances, a ship may be required to navigate in areas with a reduced underkeel clearance or UKC. It is important that the reduced UKC underkeel clearance has been planned for and clearly shown. In case where the UKC is less than 10% of the deepest draft or other such percentage as was agreed at the appraisal stage, then it is essential that the OOW is aware of such reduced UKC. He also needs to be aware that the speed may have to be reduced in order to reduce squat. With its consequent reduction in draft, information needs to be shown on the chart. The course alteration and well over. In open sea and offshore coastal waters, when navigating on small scale, large area chart, course alteration will usually coincide with the planned track intersection. This will not be the case in confined waters. When navigating with large-scale charts and where margins of safety may be so close as to require the ship to commence altering course at the well-over position, some distance before the track intersection in order to achieve the new planned track. Parallel indexing is useful method of monitoring cross-track tendency in both poor and good visibility. It is a good practice to inconspicuously mark the planned PI on the chart at the planning stage. Like any radar technique, it is advisable to practice using the PIs, parallel index, extensively in a good visibility before placing total reliance on them when thick weathers make visual navigation method impossible. Waypoints. A waypoint is a position shown on the chart where a planned change of status will occur. It will often be a change of course, but may also be an event such as end or beginning of sea passage, change of speed, pilot embarkation, an anchor station, etc. Abort areas. When approaching constrained waters, the ship may come to a position beyond which it will not be possible to do other than proceed. Term, the point of no return. It will be the position where the ship enters water so narrow that there is no room to turn, or where is it possible, where it is not possible to retrace the track due to a falling tide and insufficient underkeel clearance. Whatever reason, the plan must take into account the point of no return and the fact that thereafter the ship is committed. A position must be drawn on the chart showing the last point at which the passage can be aborted, and the ship not be committed to entry. The position of the abort points will vary with the circumstances prevailing, example, water availability, speed, turning circle, stream direction, etc. But it must be clearly shown as much as subsequent planned track to save water. The reasons for not proceeding and deciding to abort will vary according to the circumstances, but may include deviation from approach line, machinery failure or malfunction, instrument failure or malfunction, non-availability of tags or berth, dangerous situation ashore or in the harbor, sudden change in weather conditions such as onset of poor visibility or dangerous increase in wind speed or direction. The last is any situation where it is deemed unsafe to proceed. Contingencies. Having passed the abort position and the point of no return, the bridge team still needs to be aware that events may not proceed as planned and that the ship may have to take emergency action. Contingency plans need to have been made at a planning stage and clearly shown on the chart so that the OOW does not have to spend time looking for a planning safe action but has instantly available according to correct situation. Contingency planning will include alternative routes, safe anchorage, waiting areas, emergency berth. It will be appreciated that the emergency action may take the ship into areas where it is constrained by draft, in which case speed may have to be reduced, or tidally constrained areas where it can only be entered within the tidal window. Such constraints must be clearly shown on the plan. Position fixing. A variety of position fixing method is now available. It must not be assumed that any of this method will suit all circumstances. A need of primary and secondary position fixing. In order that the position fixing process is smooth and eventful and clearly understood by all concerned, the passage plan will include information to which fixing methods are to be used. For example, which one to be considered the primary method and which one are to be used as a backup secondary method. Landfall. When making a landfall, it should not be necessary for the OOW to have to minutely examine the chart to find which light will be seen first. This will have a clearly shown on the chart where their maximum visibility range so that the OOW can concentrate on actually looking for the light concerned, not looking the chart trying to discover which light should be visible. The buoyage system, the fixed wing frequency, reporting points, the pilot boarding area, chart overcrowding, planning, and master's approval. Of course, if the master like to change, he can change anyway.